All right, we have something called a rational root theorem. So if we have a function like this, I will directly get to this question to save time. If we have a function like this, again, we are looking to find values of x that will make this statement true. Off the top of our heads, it's hard to find a number for x that will make this true. So we have to break this down into bite-sized chunks. Now we have to process it, but if you see, we cannot do anything right away. We cannot factor by grouping because we won't get the same factors in the buckets, and we're kind of stuck. Now, if you could also try to use other methods, but none of the factoring methods are going to work. So we have something called a rational root theorem. What it says is that if a polynomial function has integer coefficients, then all the solutions can be given as P over Q. It's all the possible solutions. So it's going to give you a list of possibilities, and you will have to find the right one. So like The Bachelor, right? You have a list of possibilities and only one will get chosen. So what it says is take this number 20, so just write the 20 out, and designate the 20 as P, okay? What are the possible values of P? So the possible values of P are all the factors of 20, which are many. So we can start with 1, so plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, and then we have 10, and then we have 20, right? Once you get to 10, you know you can jump directly to 20. Okay, so 1, 2, 4, 5, 10, 20. The number here is a 1, and that is going to give you the options for Q. Now 1 means the only options are plus or minus 1. So all the possible rational roots are possible, right? It's not certain which one. It's just going to give you a huge list, a bank. Okay, so the possible roots are P over Q. So possible roots are P over Q. All right. And what we have here is a huge list. So P over Q. Now this time here, the plus or minus 1 is not doing anything. You just have to have all the P values, because dividing some number by plus or minus 1 leaves it as it is. Obviously the signs get flipped, but because we are checking both signs, it doesn't make a difference. So this is your list. Now that means all these are possible solutions. All of these are possible factors. Now solutions and factors are two different things, but they're related. How do I know which one is it? Well, I don't really have an easy way besides testing, so I have to test each one. So I will first take 1, and I will see if that is going to give me a remainder of 0. So I have to check. You really have to use your synthetic division tools here. You know, by now I'm sure you are well versed with this. You are a veteran. I can see the synthetic division chops showing up here. So go ahead and do some serious synthetic division, right? So keep doing it. I know you're enjoying it. And you notice that 24 is not 0. Not 0. That means 1 is not going to work. The remainder has to be 0. The remainder has to be 0. So I'm going to go ahead and do the next one. I hope this is still in focus on this camera. It looks like it might be out of focus. Here we go. I will write -1. That's the next easiest number. Again, go ahead, do some good old synthetic division. You can do this in your sleep by now, but I will try to stay awake here because I know how hard it is for you to stay awake. Okay, 11 plus 9 is 20, minus 20, and we get a 0. So yes, it is a factor. What is a factor? Remember, the sign is x minus of that. So what do we know? I can rewrite this function, I can rewrite this whole function as x plus 1, so I'm breaking down the function into bite-sized chunks. So x plus 1 is one of the factors. The other factor is the quotient. This is the quotient. So whenever you divide something and you get the remainder 0, then the big function or the big number is basically broken down into the divisor and the quotient. So we have this as the quotient, right? So we've broken it down into bite-sized chunks. You can watch the previous videos if you want some more explanation on how this comes out. So basically it's the divisor multiplied by the quotient. This only works when the remainder is 0. So the dividend, the big function, has been broken down. Now this still needs some further processing. I cannot see right away what will make this 0. So I will process it further. By now you need to know how to factor this because we've been doing this for a few months now. And I will get x minus 4 and x minus 5 from that situation. And now we can see what values of x will satisfy this equation. What values of x will satisfy this equation? Well, clearly in this case I can make this 0 by putting x as minus 1. This one could be 0 with a 4, and this could be 0 with a 5, right? As long as one of them is 0, it will make this statement true. You can also go ahead and check by substituting here to see if these three numbers make this a true statement, make this equation true. And that's how you find the roots. So break it down into bite-sized chunks. This is what they call the depressed polynomial because 3 has come down to 2. Once it comes down to 2, we know we are experts at solving quadratic equations. So there we are.